Bench power supplies are a source, and electronic loads are a sink. You know what else fits that description? Batteries. When powering devices, they are a source, and when they're charging, they are a sink or load. Speaking of those functions, this instrument from Keysight is a power supply, a load, and a battery emulator all in one. In this video, I show the E36731's basic characteristics, overview the supply and load functions, then I demonstrate how it charges, profiles, and emulates batteries while powering a unique device under test. My name is James and welcome back to Workbench Wednesdays. Let's go review. This unit came from the Element 14 community. After I am done with this video, it will go back to them for the road test program. That is where community members like yourself can submit an application to receive gear in exchange for a review. Since road testers usually do a detailed job, I am just going to give a quick overview of its capabilities. While it does fit on a bench, it probably fits better in a 3U rack. On the front is a bright LCD, a control panel, banana jacks for sense wires, and the output ports. This port requires a binding post adapter which accepts wires. It is a bit cumbersome to use. Up to 6 AWG wire inserts from the bottom, but that probably prevents blocking the front panel. However, for low current stuff, it is a little tougher to use. On the back, there are I/O ports for LAN, USB, and optional GPIB. There's also a 4-pin multifunction digital I/O port and another set of the output and sense ports. Navigating the menus is straightforward, nothing too exciting here. However, the dedicated knobs for voltage and current seem great, but they're basically useless for adjustments. Adjusting values takes forever unless you only want to change 1 millivolt or milliamp. Other test gear would let you use the arrows to select the active digit. Also, the front panel says push to 0, but I never once saw that work. Fortunately, the keypad works as expected. The screen displays either the settings, meters for the active function, or graphs. The graphs are either a data logger or an oscilloscope for the outputs. The knobs are a little more usable here, however, annoyingly, when the data logger runs, you cannot view the instantaneous values. So how do you know when the battery is done charging or discharging? At the time of this video, the base E36731A is priced at $4,775 US. But that is just the hardware. More on that later. Next, let's briefly look at the basic power supply and load functions. The power supply or source's maximum outputs are 30.9 volts and 20.6 amps up to 200 watts. 2-wire sense measures the voltage at the output ports, and 4-wire adds an additional set of wires to measure at the load, allowing the supply to compensate for loss in the cables. Also, the supply has adjustable slew rates for its output. To act as a load or sink, you must switch the function manually. When operating as a load, it has modes for constant current, voltage, resistance, and power with some low, medium, and high ranges. The user guide has details on those, but the two interesting maximums are 61.2 volts and 40.8 amps. Now, I am not going to test the maximums on either function, but based on how chunky this is, I'm not worried about those specs. Like the supply, the load function supports the 4-wire sensing. Also, there is a list feature that lets you sequence through different set points. And both functions let you make use of the digital I/O port to enable or disable the output, as well as report issues. Now, coming back to the function button, it only toggles between power supply and load. So where is the battery emulator? For that, we need to talk about some software. Despite saying battery emulator on the box, it cannot emulate or profile a battery unless you have the BV9211B Pathwave BenchView Advanced Battery Test and Emulation software. Yep, I got all the words. A license starts at $845 US and are subscription based. There are some options on how they are assigned and duration, but hey, at least you get a 7-day free trial with the box itself. Anyway, let's see how it performs. Your options are to emulate, profile, charge, discharge, and cycle batteries. The battery emulator shows key stats and a couple of graphs. Over in the settings panel, you cannot change anything until you load a profile. And here you can see I've already generated some, which I will get to in a minute, or you can load and include its sample. Let's pick the AA. Now we can change settings like the capacity, the initial state of charge, change to a 2-wire measurement, and we could even change the cutoff condition. At this point, we need a DUT to act as a load for our emulated battery. And while this personal digital assistant is slightly out of date, it has battery springs that are very easy to access. The message pad normally has this adapter to accept 4 AAA batteries in series. Since this draws less than 500 milliamps, I'm not going to use a 4-wire sense measurement in this demo. Speaking of load current, in the BenchView software, we need to make the current limit higher. And we need to put 4 virtual batteries in series since we are emulating the holder with multiple cells. Now the battery status shows us the open circuit voltage and capacity of the emulated battery. Let's start the emulation and see what happens. Okay, the bottom graph shows voltage and current across time, while the upper graph is the internal resistance and open circuit voltage as the state of charge, or SOC, goes down. And unlike the basic load, we can clearly see the instantaneous current draw. Turning on Newton, the current changes a little bit, but it does not boot. And yes, it is functional. So I had to do a little bit of troubleshooting to figure out what the problem was, and annoyingly, it was in front of me the entire time. The battery status shows the internal resistance to be about 9 ohms total, or a couple of ohms per cell. Which is weird because alkaline AA batteries usually have an internal resistance in the hundreds of milliohms. Since you cannot use an ohm meter to measure the resistance of a battery, and I have a box that can profile batteries, let's profile a real battery. While batteries often have a nominal voltage and capacity printed on them, their voltage changes with temperature. They have internal resistance, their capacity shifts over time, and a whole lot of other little details. So correctly emulating them is more than just dialing in a voltage and starting a timer. So let's profile this nickel metal hydride cell. The BenchView software creates a 200-point profile of multiple characteristics while discharging a real cell. After setting the file name, I select a rechargeable battery, set the discharge current, and enter an estimated capacity rating. The measure button is good to check to make sure that the battery is fully charged and connect it correctly. Last, for a nickel metal hydride, the cutoff is 900 millivolts. Now we hit start and see what happens.
A few moments later.
Overall, it took about 1 hour and 11 minutes to deplete the battery, which had a capacity of 2,280 milliamp hours under these conditions. The reason I use the AA profile even though Newton uses AAAs is because I only have the AA holder. For this demo though, we can consider their internal resistance close enough. Now in the BenchView software, we go back to emulate, and this time I select the profile we just generated. Since I know the real capacity, let's adjust that value and lower the current limit to 500 milliamps. Then set the state of charge to 100%, and last set up the 4 cells in series once again. At this point, it's Go Gadget Battery Emulator. And now the Newton turns on just fine. So I'm not sure why the sample, AA, and even AAA profiles have such a high internal resistance. Also, the unit measured an internal resistance around 200 milliohms, which is 10 times higher than what you would expect for a nickel metal hydride cell. And I guess maybe that's because it isn't doing a true 1 kilohertz AC measurement? I don't know. But the demo is working now. The current draw is 20 to 30 milliamps when the message pad is idle. As I start writing, the draw jumps up to almost 200 milliamps while it fails to recognize my exceptionally neat handwriting. Looking at the voltage current graph, you can see how just like modern portable devices, Newton has a very dynamic power usage. Another way to use a battery emulator is to drop the capacity to see how the device responds. Here you can see that as I lower the state of charge, the emulated voltage drops. The resistance goes down, and the Newton shows reduced capacity as well. For product development of a battery-powered device, those emulation features can save a ton of time. Plus, you don't have to worry about having certain dangerous battery types in the lab. Alright, I need to mention a few other things before we close. In the profiler, we only did a discharge curve, but the analyzer can also create one for charging. There is a function called charge and discharge, which does exactly what it sounds like. I did not get a chance to try the cycler, which would let you create a charge-discharge cycle so that you can see how the battery ages. Nor did I show in the profiler how you can create a dynamic load instead of just using constant current. Also, you can profile with multiple ambient temperatures. I skipped over some other things like the pulse current and rest time. At first, I did not know what those options actually did, and when I tried to search for a manual, all I could find was this brief brochure which doesn't even mention them. However, by pressing F1, I could see that the built-in help does have words associated with all of those input boxes. Now that I have done my short evaluation, make sure you check the link below to see what the road testers on the Element 14 community think about it too. Hey, thanks for watching. Check the link below for show notes on the Element 14 community. You'll find lots of great stuff over there. If you want to see more videos from me or the other hosts, tap or click the things on the screen. For now, it is time for me to get back to my electronics workbench.